Have you ever wondered why, during some solar eclipses, the entire world just seems to pause, as the sky is completely plunged into this eerie darkness, while during others, a brilliant burning ring of fire is left blazing up in the sky? Well, the answer to that all comes down to a really breathtaking game of celestial geometry. Hello, and welcome to this explainer. Let's untangle the mechanics behind one of nature's absolutely most dramatic visual spectacles.
Today, we're taking a deep dive into the official source material from NASA Science to bring you this cosmic geometry explainer. We're going to break down exactly how the Earth, the Moon, and the Sun align to create 4 distinct, truly awe-inspiring types of solar eclipses. If you love understanding exactly how our universe works through clear step-by-step visuals, you are definitely in the right place.
Here's our roadmap for today. First, the cosmic alignment. Then, the total solar eclipse, followed by rings and crescents. After that, the rare hybrid eclipse, and finally, essential viewing safety.
Section 1. The cosmic alignment, the baseline setup.
So, a question that comes up a lot is, if the Moon orbits Earth every single month, why don't we have an eclipse every month? Well, it's simply because the Moon doesn't orbit perfectly flatly alongside the Earth and Sun. Imagine 2 hula hoops layered on top of each other, but one is tilted just slightly. Because of that tilt, we only enter what's called eclipse season, roughly twice a year. That's the specific window of time when those orbits perfectly intersect on the exact same plane.
And when that seasonal alignment finally happens, the cosmic dance really begins. The sequence is beautifully simple. Step 1. The Sun constantly emits light. Step 2. The Moon passes exactly between the Sun and Earth. And Step 3. The Moon intercepts that light, casting a physical shadow right down onto the Earth. It's honestly just like holding a tennis ball in front of a flashlight. If you happen to be standing in that shadow, boom, you experience a solar eclipse.
Section 2. The total solar eclipse, the perfect block.
Okay, let's dive right into this. A total solar eclipse is exactly what it sounds like. It happens when the Moon passes between the Sun and Earth, and just perfectly, completely blocks the face of the Sun. But here's the catch. This absolute blackout only happens for people located perfectly in the center of the Moon's shadow as it sweeps across the Earth's surface. You literally have to be in exactly the right place at exactly the right time to catch this perfect block.
Now, if you are lucky enough to be standing in that shadow, the transformation is mind-blowing. In just a matter of minutes, a normal, bright daytime plunges into this sudden, deep twilight. NASA actually describes it as if dawn or dusk were happening right in the middle of the day. And with that blinding sun completely obscured, its wispy outer atmosphere, which we call the corona, is suddenly revealed in the sky.
Section 3. Rings and crescents, the distance variable.
So the Moon's orbit around Earth is actually an ellipse, meaning its physical distance from us fluctuates. An annular solar eclipse happens when the Moon aligns perfectly with the Sun, but it happens to be at or near its absolute farthest point from Earth. Think of holding a coin right up against your eye versus holding it way out at arm's length. Because the Moon is farther away during an annular eclipse, it naturally appears just a bit smaller in our sky. And because of that smaller visual footprint, the Moon simply cannot completely cover the Sun the way it does during a perfect total eclipse. Instead, the Moon appears as this stark, dark disk layered right over a much larger, bright disk. It leaves those fiery outer edges entirely exposed, which creates a brilliant ring of fire. Now, let's shift our alignment variable just one more time to create a partial eclipse. This happens when the Moon passes between the Sun and Earth, but the 3 bodies are not perfectly lined up in a straight row. The geometry is just slightly off-center. Because that alignment is off, only a fraction of the Moon's dark silhouette actually passes in front of the Sun, giving our star this really distinct crescent shape. It's also super important to remember that even during a perfect total or annular eclipse, anyone standing just outside of that concentrated inner shadow is only going to see this partial crescent eclipse. Section 4. The rare hybrid eclipse, the curvature curveball.
All right, we have to remember one undeniable fact here. The Earth is not flat. It's a sphere. And because the Earth's surface literally curves away from the Moon, the actual physical distance between the surface of the Earth and the Moon's moving shadow changes dynamically as that shadow sweeps across the globe.
Because of that changing distance created by the Earth's curve, we get what's called a hybrid solar eclipse. And guys, this is incredibly rare.
What happens is the eclipse literally shifts between being annular and total as it travels. So observers in one part of the world might see an annular ring of fire because the Earth's surface curves away from the moon there, while observers farther along the path might experience a total blackout as the Earth's curve bulges slightly closer to the moon, allowing the shadow to perfectly cover the sun. It is literally two breathtaking eclipses bundled into one single event.
So let's quickly cement these variables in our minds. If the alignment is perfect and the moon is close, you get a total eclipse with a blocked sun and a visible corona. Perfect alignment, but the moon is far away, you get an annular eclipse with that bright ring. An imperfect line yields a partial crescent shape. And if the distance changes mid-eclipse due to the Earth's curve, you get the shifting hybrid eclipse. 4 absolutely incredible phenomena, all dictated by elegant cosmic geometry.
Section 5. Essential Viewing Safety, the Golden Rule.
Now listen closely, because looking directly at the sun causes severe permanent eye damage. You absolutely must always use properly certified eclipse glasses or a safe alternative method, like an indirect pinhole projector. And please remember, never use regular sunglasses. I don't care how dark they are, they do absolutely nothing to protect your eyes from that intense solar radiation.
You really need to keep those certified glasses firmly on your face for the vast majority of your viewing experience. You absolutely must use protection for the entire duration of a partial eclipse, the entire duration of an annular eclipse, because that ring of fire is still intensely bright direct sunlight. And you've got to wear them before and after totality during a total eclipse.
Now, there is only one single exception to this rule. The only time it is safe to momentarily remove your eclipse glasses is during the very brief period of absolute totality during a total solar eclipse. When the moon has 100% blocked the bright face of the sun and it gets dark outside like dusk, then it is safe to look at the corona with your naked eye. But the actual second the sun begins to peek out again, those glasses must immediately go back on.
To really drive this home, let's look at a direct quote straight from the NASA source material. Quote, "Except for the fleeting moments of totality, observers should always use eclipse glasses or an alternative safe solar viewing method." End quote. It really couldn't be clearer, could it? This incredible geometry is just a joy to witness, but we have to respect the power of our star and protect our vision while doing so.
And that brings us to the end of our geometric journey. We've seen exactly how precise alignments, varying distances, and even the curvature of our own planet dictate the shadows that get cast across our world. So I leave you with this question. Which of these 4 spectacular cosmic alignments will you be looking out for safely during the next eclipse season? Stay curious, keep looking up safely, and thank you so much for joining me on this explainer.